Hey there, Sahara and Luke. Just some list up here. So let me share my screen. Share screen. Okay. So um, this is Introduction to Living Soil, and our vision is going towards nutrient-dense food. Last week was class 1. It was introduction, and we went over the FTP site. I tried to learn about folks' gardening stories. That's been mostly like going to people's homesteads, kind of seeing what their situation is. And then we have the NRCS USDA soil map, and so that is an important part of using tools we have at our disposal to find the soil type, the native soil type at our location. So we went over that, and then basics on like types of soil, silt, clay, sand, and how those are used to classify different categories of soil. And then based on silt, clay, sand is based off of sieves for this particle size. Types are based off of combinations of like all clay, all silt, all sand in a pyramid. And then there's an extrusion test you can do. And that also has like you make a paste and you see how much grit is in there. So that's a way to figure out what type you have at your home without a full lab analysis. The last thing was my favorite PDF on farming as a spiritual discipline. It kind of gets you to slow down and realize that plants take a while to develop, as does long-term growth. There can be an explosion and definitely like milestones and transitions and amazing moments, but the process on a whole is analogous to things we see in farming, which are larger systems that build topsoil over time and develop um, like 1 month of growth for a radish, that that's not appreciated in the store. So that was that. Class 2 today, it's going to be kind of the history of organic farming coming from India through Europe to the United States. And then some of the concepts that you'll need to know on soil tests, macro, micro, pH, traditional fertility versus Steve Solomon's fertility approach. pH, how it relates to hydrogen cations and what are the other cations and some of the history we'll go over the sweet spot for balancing cations in the soil. And then we'll get into cation exchange capacity and a little bit on Steve Solomon's fertility approach. So that's today. And then tomorrow or next Wednesday is the actually working through Steve Solomon's spreadsheets to create a customized fertilizer for our soil. This week is going to include some reference to my buddy Luai's soil results. He got those back, and so we'll kind of look at 2 different spots at his house and what sticks out. Okay, let's get into it. So this is class 2, Intro to Living Soil, chapter 6, some of the history of organic farming. So this guy, Sir Albert Howard, was an English botanist and the first Westerner to document and publish the Vedic agricultural practices in India. These techniques of sustainable agriculture are now known as organic farming. They were building the soil. They were using green manures, and they had other aspects that we consider organic that they were doing. Some of the crop rotation stuff came from them. So basically, Vandana Shiva and I don't know how to say that, Rajiv, had that. There was a kind of interview between them two on YouTube, and it's interesting just how the West, 100 years ago, was going to teach them how to do mass production, and he actually saw that the Indian farming was more advanced than Europe. So he appropriated what was happening in India, and that reached back to England, and they made their own, version of it, and that just kind of moved them away from manure only applications, but green manure and crop rotation. And then they became owners of this idea that wasn't theirs, and then they twisted the meaning and they exported it back to the indigenous people of India, within their enterprise, within their superpower of that time. So it is kind of dark, but also that's how America, J.I. Rodale Institute, that's how they got some of these ideas from India. And so as America consumed that, they started doing a kind of a check on just the manure only approach, and so I'm not fully. Yeah, this is something like what happened. So there was one way that farming was done in Europe that was brought to the United States. There was Indian methods that were brought back to England, and some of those were brought into America and started to question the traditional organic approach. So this guy, he was kind of in parallel to this effort, investigating grasses that didn't look healthy versus grasses that were healthy, and the types of soil that produced those in Missouri. There's like the Badlands, and why are the Badlands bad was his question. So as William Albrecht looked into it, he found that there was a ideal balance of cations, which we'll get into later. And this is calcium 10%, calcium 60 to 75%, magnesium 10 to 20, and potassium 2 to 5, and sodium 0.5 to 5%. So Steve Solomon took William Albrecht's work into account in his soil fertility approach. So there was a large focus on pH back then, and there's pH is more complex, and so he's talking about the sweet point of the soil where cations are being exchanged, and so that is more than just a simple fundamental pH focus. We'll talk about that too in a second. So here's Steve Solomon, based on William Albrecht, incorporating some of the Indian practices, that the idea of organic as it developed away from manure only focus. So he was in 73 back to the land movement. He tried to subsist off of the land. And when you start to do that, you need to have balanced soil, because as he started a seed company, He his teeth got loose and his daughter's fingers got soft because there was a mineralization issue, which he figured out in 1984. He took a sabbatical to Fiji's Sagatoka Valley, and the food there was, produced off of the floodplains of a river. And just in a couple months, they had their teeth solid, and his daughter's fingernails were harder. So that's kind of the impetus that got him into his fertility approach, which is remineralization, and it involves the right mix of amendments to ensure there are proper balance in the soil. And that means better tasting food that's healthier and that is dense in nutrients instead of like like a bad tasting tomato that was grown for shipping, or something that was grown for weight at the compromise of like a heirloom variety or something like that. So this is his book, The Intelligent Gardener, Growing Dense Food. So this book actually has the spreadsheets we'll use for figuring out our fertility scheme. And he basically wants to encourage people around the world to be a neighborhood soil analysis where they collect soil samples, work with Logan Labs, and have extra minerals that they can mix up a specific mix for people's land, so that it doesn't have to be, buy a 50-pound bag of this and a 50-pound bag of that for a small farmer, a small gardener. So my buddy Chris at Big Leaf Farm has helped me get going. He shared his minerals, and we have extra here too. All right, chapter 2, Intro to Living Soil, Macronutrients, Micronutrients, pH, Traditional Fertility. And I'm including also a little bit on cations in this chapter. So here is a soil analysis report. The micronutrients are down here. These are the ones that you need in your body that cause the taste to be amazing. Odwalla carrot. These are the macronutrients here that you need to have anything to even grow. NPK, N, P, and K. And then these are the cations that are also over here with their charge in the soil. So the pH is inversely proportional to the amount of hydrogen you have. So if you have more hydrogen, you have more acidic. And as these are also positively charged, just like hydrogen. So as you have a better balance and more of these in your soil that the plant needs, you get closer to 6, 5, 7, because there's less hydrogen. It's more these cations. So that's where it's kind of a complex system here. You could have the right pH, but have these out of balance and not have a good cation exchange capacity, which is this CEC right here. So that's a small intro. The soil fertility guidelines here from A&L Labs. This is A&L in Tigard. This is going to focus kind of on a, you want to get the biggest vegetable possible. This is not a nutrient dense focus. And so Steve's going to be reducing potassium in his mix, and he's going to make sure all the micronutrients are in there, including some that the body picks up that the plant doesn't even use. So, and then he's going to be thinking about balancing this. So that's kind of some of the difference from a soil fertility is just focused on getting the most weight out of your produce versus something that's geared towards nutrient dense. There's a bunch of other stuff on here, like nitrogen. this is usually just like you need 150 pounds per acre every year because it leaches out. So it's not always included in Steve Solomon's fertility mix because it's assumed you got to put that on. You have to have a nitrogen source every year. And organic matter allows you to have a spot, increases your CEC so that you can put CEC is how much nutrients you can push into your soil. So if you have a CEC of 0, you basically have sand. So this organic matter allows you to be able to hold more nutrients as a cation in the soil. So soil is electric. It's all about um, charges on soil and being able to hold these so they don't leach out, which is all included in here. All right, what do we have next? So cation it comes from Greek meaning going down. So that if you lose one electron, then you're going to have a positively charged atom or groups of atom. So that's cation. If you have an anion, that means going up. That means you gained an electron, positively charged ion, and so that means you've gained an electron. You have a negatively charged ion. So this is a little bit abstract. It came from Michael Faraday in the 1830s, what I found, but that is what we have. And then I mentioned before, pH is inversely proportional to how much hydrogen you have logarithmically. So a 7 and a 6 are completely different. But hydrogen are a cation. So that means they've lost one of their valence electrons, or a group of atoms had a loss of electrons collectively. So that's what I found on that. And so here's an example. See, these H's would be like more hydrogen in the soil on these clay or organic matter particles. And so you're going to have decreased pH. But over here, you start to have no hydrogen, but you get these other cations that are taking the place of that. And it actually changes the soil charge so that it can hold more. It's kind of like like a magnet that can magnetize something, and then that thing keeps the magnet direction. That's kind of the same thing. It's like these are magnetizing the thing that it's stuck to and making it more apt to hold more positive charges. So by the time you get over here, it's kind of like this the pH that is most effective, 6 to 7. Then you have all of these are plant minerals, and there's no hydrogen, a lot less hydrogen. And then the balance of these, if it's at the proportions that William Albright found, can really start to hum as soil and be able to pass nutrients to your plant. And so this is the Steve Solomon approach that we're taking. We've taken this approach for a few years, and it has produced better tasting carrots. So there's a link here for that this came from. This graph's just kind of showing that when you're between 6 and 6.5, you have the most available nutritional elements. And so that's why when you're really acidic, the elements aren't free flowing, or I don't exactly know all the reasons why they're not available, but in this little chart, they're thicker here at least. So I thought that was interesting. Okay, now I've talked about cation exchange capacity. That this is a really cool thing, the way that it works, because cations are exchanged within the soil root zone, and they're not easily lost through leaching with water because they're electrically connected to the clay and organic matter. So the absorbed cations may easily exchange with other cations. Yeah, once you have the soil set up correctly, stuff can flow back and forth, and it opens up. The soil tilt is different at that right balance of cations. And how it works is when the root is growing from your plant, it actually has mucus around the plant root hairs, and that has cations in it that release that are exchanged with the soil in a local area, so the plant can eat the healthy cations. So it's kind of like the plant has cations that are offered to the area in which the fertility is, and then it can consume that. But then they're not released until that plant is there to exchange it. And Luai mentioned to me there's some stuff in the body that works like that too. So it's a way to get food at the right time. All right, so review NPK: nitrogen, phosphorus, potassium. Potassium is potash, and this Solomon restricts because it causes your stuff to grow tall, and we want to have nutrient dense. So we want it to be thick and not grow too tall. We want it to taste good. So Solomon restricts this, but whereas other fertility schemes might not. So what would 14-14-14 have in it? Anybody know? That is a fertilizer that has that 14% of the weight is nitrogen, 14% of the entire weight is phosphorus, and 14% of the weight, after you in the lab, got just pure potassium out of it, that amount of potassium would be 14% of the total weight. So this is a common like NPK approach to listing fertility on the side of inputs. Oh yeah, this is if you overdo the potassium, it has more selling weight, it has more starch, but it has a quarter less protein and a quarter less minerals and vitamins than if you had restricted the potassium. So it's tasteless means it also doesn't have nutrients. And it causes people to overeat because they're looking for that protein and that mineral and those vitamins. And your McDonald's French fry, I'm going to give you a tip here. They're looking at the weight and the selling weight. They don't give a damn about if they're producing nutrient dense food. Sorry, Ronald. Okay, so here is another description of the same soil fertility and soil analysis report. So Steve Solomon says some of these elements, these 6, you can hit on the bullseye and you can really dial these in your soil. Calcium, magnesium, potassium, sodium, sulfur, and phosphorus are all things that you can see on a test and that you can make a fertility to get that where you want it to be. Some of these you can mostly target. They're supporting elements. They're kind of in less quantity of micronutrients. So these are harder to get where you want because there's like when you're mixing your fertilizer, you have to get it all mixed up, getting it placed properly. So that's a little bit harder. And then at the end here, are the ones where these are good for the human. This helps the human, but the plant doesn't need these at all. So as you're looking at your fertilizer, your traditional soil analysis might not say you need these, but they are needed for humans. So some of that kind of stuff is specifically Steve Solomon's approach based off of his loose teeth. So this is the Logan report. So this is what Steve Solomon's going to ask us to use as Logan Labs. So it's a little bit more tabular, but the results it produces and the way that they do their test, the Malek 3 test, this is what he's geared his formulas for. So Logan Labs is what we have to use his spreadsheet. So there's top and the bottom. Top, exchangeable cations we've been talking about. Sulfur is an anion as well as phosphorus. These are the micronutrients, trace elements. They have a base saturation percent. So this is the percentages that William Albright came up with here, if you remember. All right. On this test, you can see the pH is a bit off. You come up here. The pH is 5.8, so that's ridiculous. And you can tell that because there's lots of hydrogen over that William Albrecht's 10% goal. Okay, so what is sample depth? I'm not sure if we totally got into that, but on Logan Lab's webpage, they have, if you go to Logan Lab, they have under send a sample. These under send a sample, loganlabs.com, send a sample. Step 1, choosing your test. So you're going to want just a standard soil analysis here. And then the submission worksheet is pretty straightforward. And this is the bit on collecting your sample. So this is where it tells you here on this video how to take a soil sample, how to use a shovel, and basically.
Now you can put it in a freezer bag.
So can you see how he has this little black tape on here? That's 6 inches deep. So he's gonna do a slice in the soil, and then he's gonna do a back. He's gonna do a back cut right here. So he made a hole. Now he's doing a 1-inch back cut, and he's gonna use that 6-inch profile to put in a bag. And he needs 2 cups to send to Logan Labs. And so that's as simple as it is. If you have multiple samples, you gotta like label them on the bag and stuff like that. But the instructions are pretty good. And so liming. So usually, how my mentor does his farming is things that are not water soluble, like calcium, lime. He can do in the fall, and it takes a couple months for the calcium to get going. So you want to get the calcium in your soil in the fall before you farm on a field. And then, things like nitrogen is water soluble. So you wouldn't want to put your nitrogen on until you're actually planting the plant. And then you want to be like side dressing it at the appropriate time and with not too much, not too little nitrogen, for example. So lime is like egg lime you can get from Fisher Mills by Oregon City. And that is a powder, so you have to use a drop spreader. We have a big drop spreader we pull behind tractor, and the drop spreader there's like a junkyard of drop spreaders at Fisher's Mill, so you can just buy a 100-year-old drop spreader. We talked about cation exchange capacity and the cool thing that roots do. A lot of stuff is in pound per acre. Like if we look at the recommendation for soil fertility, this is in pound per acre. So sometimes you have to work backwards to have it be, pound per one of your rows. So my rows are 100 feet, and my tiller is 4 feet wide. So I need to know how much I need for one tilling, and so our spreadsheet will adjust from pound per acre to something that we can put in a bucket. So that's good to know. pH is the best indicator? No, it's got to be in conjunction with cation balance. What is organic matter? Organic matter is similar to clay in that it holds nutrients. It's got a negative charge to those particles, and so that can have a lot of cations attached to it. That's my understanding. Banding is where you just put fertilizer, like with the drop spreader, you're going to probably be spreading it over your whole field and till that in. So that's not banding. Banding would be like where you just put nitrogen or nutrients, minerals in one row where you're going to plant. And the thing with that is the next year when you take a soils test, you kind of need to know where you're going to take it. If you've already put fertility in some areas, not in others, then you have to kind of keep track of that. Or you need to have enough fertilizer just to fertilize your whole garden. And so everything in your garden, it will be the same nutrient fertility. Initial fertilizer, I don't know what that means. Side dress, I think like half to 2/3 of my nitrogen that the 150 per acre, I will side dress and put kind of like along with the drip line, so that the plant can eat that nitrogen as it gets going. There's a whole trick to side dressing. I think I like overdid side dressing, and I use chicken manure, which is really hot. And one year all my broccoli started bolting, and then because it was bolting, I had pest pressure because it was a vulnerable plant. So some of my interns will remember that year. And Logan Labs. Oh yeah, some of these minerals will be toxic, sulfur, boron. So even no matter what you do with your fertilizer mix, you don't want to be putting more than a certain amount on your garden, even if it says you need more, because if you get it wrong and you have concentrations that didn't mix up in your fertilizer, you will see a dead spot in your garden that won't grow anything. So that is a sensitivity you need to be aware of. So let's see if there's anything else. Here's another picture of a good CEC 25. And you can see the clay has lots of spots where it can take cations. They're all like sticking in here and happy. And then sand doesn't have as many spots for, it's actually quite a bit less spots for particles to stick on and transfer. So if true sand is like 0 on the CEC range, 50 is heavy clay. Here's like the roots. The roots are releasing their own hydrogen. When microbes feed on roots, they exudate hydrogen ions that are released in great quantity as a byproduct. So the plant is releasing hydrogen ions. There's this microbe activity, and that frees up the magnesium, potassium, iron, calcium cations that are absorbed by the root, which this is a local freeing up of nutrients, and that is an electrical exchange that happens, so that when it rains, they don't just all fall out. They're only transferred for a moment there. That is so cool. I am a theist here. Okay, so here's another picture of the same thing. The clay particle, which is negatively charged, binds cations. The cations are exchanged for hydrogen ions obtained from the carbonic acid from the plant itself in this process on these root hairs. Mineral cations are released into the soil solution and the plant gets. Okay, so a little bit on Steve Solomon's philosophy that we're going to go over next week. I don't overlook any elements the plants can pick up, because even if the plants don't seem to require them, your body does. Creating soil fertility is not about more, it's about achieving balance. Present the plant and soil ecology with a luxurious abundance of everything they can use except potassium. So we mentioned those previously. All right, that's it. Give me a shout if you like. Aharon, AHAROWN at aslanshorganics.com.